In this video, we are going to see why we need disk scheduling algorithm and some of the terms to understand disk scheduling and many disk scheduling algorithms with examples. As of we know, a process needs two types of time, CPU time and input output time. For input output, it requires the operating system to access the disk. However, the operating system must be fair enough to satisfy each request, and at the same time, operating system must maintain the efficiency and speed of process execution. The technique that operating system uses to determine the request which is to be satisfied next is called disk scheduling. Then some of the terms here: seek time. It's the time taken in locating the disk arm to a specified track where the read or write request will be satisfied. Rotational latency is the time taken by the desired sector to rotate itself to the position from where it can access the read write heads. And transfer time is the time taken to transfer the data. Disk access time is given as the sum of rotational latency plus seek time plus transfer time. Disk response time is the average of time spent by each request waiting for the input output operation. And purpose of disk scheduling here is to select a disk request from the queue of input output request and decide the schedule when this request will be processed. The goal of disk scheduling algorithms is to implement fairness, high throughput, minimal traveling head time. The first scheduling algorithm is first come first served scheduling algorithm. It is the simplest scheduling algorithm. It services the input output request in the order in which they arrive. There is no starvation in this algorithm. Every request is serviced. Disadvantages includes the scheme does not optimize the seek time. The request may come from different processes. Therefore, there is the possibility of inappropriate movement of head. So, in order to understand the first come first served scheduling algorithm, we have an example here. Consider the following disk request sequence for a disk with 100 tracks: 45, 21, 67, 90, 4, 50, 89, 52, 61, 87, and 25. The head pointer starting at 50. Now, the head pointer is at the track 50 and moving in the left direction. So find the number of head movements in cylinders using first come first served scheduling algorithm. Since this is a 100 tracks, we start from 0 to 99. The head pointer is now at 50. Track at 50. Now the first request came for 45. So from 50 we move 45. From 45 next request 21. From 21 next request 67. The next request 90. From 90 next request 4. Next request from 4 50 and then 89, 52, 61, 87, 25. So now we have to find the head movements here. So here we can find using the multiplication. Now here from 50 to 45, 5. From 45 to 21, 45 minus 21, 24. From 21 to 67, 67 minus 21, 46. From 67 to 90, 90 minus 67, 23. From 90 to 4, so 90 minus 4, 86. And then 46, 50, 4 to 50, 50 minus 4, 46. From 50 to 89, 89 minus 50, 39. 89 to 50, 89 minus 52, 37. From 52 to 67, 61 minus 52, 9. From 61 to 87, 87 minus 61, 26. And from 87 to 25, 87 minus 25, 62. So sum of these all cylinders movement is 453. The next scheduling algorithm, shortest seek time first scheduling algorithm. It selects the disk input output request which requires the least disk or movement from its current position regardless of the direction. It reduces the total seek time as compared to first come, first served scheduling algorithm. It allows the head to move to the closest track in the service queue. Disadvantages of this algorithm: it may cause starvation for some requests. Switching direction on the frequent basis slows the working of algorithm, and it is not the most optimal algorithm. So here what we are going to do, we are going to seek time. We are going to find the minimum seek time and move the track in that direction. Here we have an example. Consider the following disk request sequence for a disk with 100 tracks: 45, 21, 67, 90, 4, 89, 52, 61, 87, and 25. Now the head pointer starting at 50. So since this is a 100 track, we start from 0 to 99. Now the head position is at 50. The closest track from 50 here is 52. So only two movements, and then 45 here we need of 5 movements, so we choose 52. From 50 to 52. From 52, the closest location is 45. Among these all the requests, the closest location is 45. So move to 45. And then from 45, the closest location here is 61. From 61, the closest request here is 67. From 67, the closest request here is 87. From 87, the closest request 89. From 89, the closest request 90. From 90, the closest request here is 25, because all the requests are satisfied. So 25. From 25, the closest request is 21. From 21, the closest request only the left one is 4. So the 4 is satisfied. Now we have to find the disk movements. Here you can see from 50 to 52. So 2. From 52 to 45, 7. From 45 to 61, 61 minus 45, 16. From 61 to 67, 6. From 67 to 87, 87 minus 67, 20. From 87 to 89, 2. From 89 to 90, 1. From 90 to 25, 65. From 25 to 21, 4. From 21 to 4, 70. So the sum of all these number of head movements is equal to 140. Next algorithm, scan scheduling algorithm, also known as elevator algorithm. In this algorithm, the disk arm moves into a particular direction till the end, satisfying all the requests coming in its path, and then it turns back and moves in reverse direction, satisfying requests coming in its path. It works in the way an elevator works. Elevator moves in a direction completely till the last floor of the direction and then turns back. We have an example to understand the scan algorithm. Here, consider the following disk request sequence for a disk with 200 tracks. 98, the requests are 98, 137, 122, 183, 14, 133, 65, 78, and head pointer starting at 54 and moving in the left direction. Now we have to complete the left direction and then to the right direction. Find the number of head movements in cylinders using scan scheduling. Here we start from 0 to 199 because we have 200 tracks. Now we are at the location 54 and it moves in the left direction, from left direction. So 54 to, from 54 to 14. Start from 54 and it moves in the left direction. In that direction we have a request for 14 and to the end 0. Moves to the end and again it's start to the right direction. It's completes its direction in the left, and now it will satisfy all the requests in the right direction. The next request in the right direction here is 65, and then 78, and then 198, and then 122, 133, 137, and 183. So here you can see the algorithm scans in the left direction to the end, and starts from the end of left to the right. So end to the right direction and satisfies all the requests in that direction. Now we have to find the head movements here. Here from 60 to 14, 40, from 14 to 0, 14, from 0 to 65, 65, and then 65 to 38, 78, 13, 78 to 98, 20, 98 to 122, 24, 122 to 133, 11, 133 to 137, 4, 137 to 183, 46. So sum of all these numbers is equal to 237. For scan algorithm, the simplest, easiest way here is from 54 to 0. So 54 here, 54, and from 0 to 183. So 183 plus 54 will give you 257. It is the easiest way to find the number of head movements needed. The next algorithm, C-scan, circular scan scheduling algorithm. C-scan means circular scan algorithm. The arm of the disk moves in a particular direction, servicing request until it reaches the last cylinder. Then it jumps to the last cylinder of the opposite direction without servicing any request. Then it turns back and starts moving in that direction, servicing the remaining request. So we have an example to understand the C-scan, circular scan algorithm. The same question. Consider the following disk request sequence for a disk with 200 tracks. Request in the order 98, 137, 122, 183, 14, 133, 65, and 78. The head pointer is at the location 54 and moving in the left direction. So we have to find the number of head movements in cylinders using circular scan scheduling. So we start from 0 to 199. We are at the location 54. We are at the location 54. Now this is the circular scan algorithm. Here you can see from 54 to 14. From 54 to 14, and then from 14 to 0. Now here, now in this direction is completed. The left direction is completed. In the opposite, it is not going to service any request. It is going to the entire, it is skip the entire circular. Here from 0 to 199, it won't satisfy any request. Here you can see. So in that order, from here, from this end to the another end, the no requests are satisfied. Again, in this order, from the left direction only, the requests are going to be satisfied. From 199, from 183, and then to 137, 122, to 98 and 78 and 65. So that's the last one. So here you can see we start at 54 and moves in the left direction. So servicing all the requests, and when it turns here, it won't service any request and goes to another end and starts servicing in the again in left direction. Okay, now we have to find the number of head movements here from 54 to 0, from 54 to 0, 54, and from 0 to 199. So 199 plus 54 plus 199 minus 65. 199 minus 100, from 199 to 65. So it will give you 387. The sum of all these requests is 387. The next algorithm, look scheduling. It is like scan scheduling algorithm to some extent, except the difference that in this scheduling algorithm, the arm of the disk stops moving inwards or outwards when no more request in that direction exist. This algorithm tries to overcome the overhead of scan algorithm, which forces the disk arm to move in one direction till the end, regardless of knowing if any request exist in that direction or not. Here we have an example to understand look scheduling algorithm. The same question, the head starting at 54 by using look scheduling algorithm. We start from 0 to 199. We are at the location 54. Now from 54 to 14, and you can see Here it's a look scheduling, not a scan scheduling. Scan will go for 0 to the end, but here there is no request for 0. There is no request for 0. So it won't move to the end, but it changes its direction. It services the next request by not going into the end. By not going to the end. From 14 to 65, servicing the next request, and then 78, and then 98, and then 122 to 133, 137, and 103. Now we can see the disk movements won't go for in the final, in the end. So this overhead is reduced in look scheduling. We can find out the head movements here from 40, from 54 to 14. So 15, from 14 to 183. So the sum of all these numbers will give you 209. The next scheduling algorithm, C-look, circular look algorithm. It is similar to circular scan algorithm to some extent. In this algorithm, the arm of the disk moves outwards, servicing request until it reaches the highest request cylinder. Then it jumps to the lowest request cylinder without servicing any request. Then it again start moving outwards. Servicing the remaining request. It is different from the circular scan algorithm in the sense that circular scan force the disk arm to move till the last cylinder, regardless of knowing whether any request is to be serviced on that cylinder or not. We will understand the look by have an example. The same question with the head starting at 50. See, we start from 0 to 199. Now here from 54 to 65, and then 878, and then 98, and then 122, 133, 137, 183. So here there is no request here. There is no other request in that dash. So from 183 to 14. So here the direction, in that direction it won't service the there is no request in that direction, so it changes its direction and completes its request. So here we can find out the number of cylinders crossed here from 54 to 183, and from 183 to 14 it will give you 290. So if you work more on these algorithms by giving more, by attending more questions, then you can able to attend the questions in within a minute.